again, thank you so much for your effort, and the grades overall were very good. I'm very happy. Okay, so we are back to 3.
Before we start the
Yes?
it was from 3.1.
Yes, I'm ready. From 3.1.
And it's y equals 4e to the x plus 7 over the cubed root of x. And then one of the derivative.
Yes, like this?
Yes.
Okay, so first, always simplify it, because it's always easier to differentiate this than something like that. You don't want to use the quotient rule on, especially when the numerator is a constant. You don't want to use the quotient rule. There is no need. Can you? Yeah, but there is no need. So either dy over dx or y prime will be 4e to the x. I have to bring negative 1/3 in front, so I have to multiply by 7. And then x, and the negative 1/3 minus 1 is negative 4/3. So that's why the power will be negative 4/3. Is that okay?
Yep.
Is that all you needed?
And that's what I had. But I don't know. I'll try putting it in again later.
Yeah, who knows? Maybe you typed it in incorrectly. Yeah, it's kind of fidgety. Good. Next question. Is there anything else?
Can we go over a question on the homework?
I'm ready. I'm going to post the solutions with a video now. But it doesn't matter. I'm ready.
Number 18. Y equals sine of t divided by 1 plus tangent of t.
Very good. So let's do just that. So y prime or dy over dx, same thing. It's a quotient. I have to use the quotient rule. I prefer, not necessarily and not always, get rid of the denominator ASAP. I differentiate the top. Can anyone tell us what is the derivative of sine?
Negative cosine.
So the derivative of sine is cosine. So sine t prime is cosine t, but cosine t prime is negative sine t. So this will be cosine t. We multiply by the denominator, and we subtract. The numerator now stays as is, and we differentiate the denominator. Can anyone tell us what is tangent prime?
Secant squared x.
I wouldn't attempt anything else here. You can change cosine t, distribute cosine t, and then when you multiply, sine over cosine by cosine will be just sine t. You can change this into 1 minus 10. There is no need. This is it. That's all I need. Even if you distribute, it's not going to simplify. Is this okay?
Yeah, I was just confused if you want us to simplify any further. Because I got there,
No,
but then
you can't.
Okay, I think.
Before I forget, the interim grades are due tomorrow. These are not grades that are part of your final letter grade, but they are just an assessment of your work so far. So, however, please take them seriously. Okay, is there anything else from me? Do you have anything else? Any other questions? Anyone?
I have one.
Yes. Ready.
Can we go over a of s equals negative 13 over s to the power of 6?
Say it again. A of s equals?
Negative 13 over s to the power of 6.
Okay, so I will write negative 13 times s to negative 6. And if I'm asked to differentiate, I'm assuming that's what I'm doing. I will bring down negative 6. It will change to positive. So this is, I think, 78. And s to negative 7. So this is 78 over s to the 7th power.
Okay, thank you.
Thank you. Anything else, anyone? Okay, so then we're back to finish up section 3.3. And again, we had that limit. I'm going to copy it again. As long as all these pieces are the same. The answer is 1. So let's go back and choose some more problems. I would like to look at, feel free to choose from the end of 3.3. In the meantime, I'm going to work on this problem. Limit as x approaches 1 from sine x minus 1 divided by x squared plus x minus 2. Okay, so when we are asked to find the limit, what do we have to do first?
Simplify.
Say it again, Gabriel.
It was 10.
Oh, 10. I'm sorry. 10.
Simplify the function.
We have to plug it in first of all. We have to plug it in because maybe the answer is 5 and I'm done. So we have to plug it in. When we plug in 1, what do we get at the top?
10 and 0.
Good. And the denominator?
0.
Good. Now, I wish I could say, well, there must be a factor of x minus 1 that we have to remove from top and bottom. I can't. I cannot say that because x minus 1 is inside another function. So I can never factor out x minus 1 at the top. So that situation is not applicable here. Okay. So what will be our next choice? Since I cannot touch sine x minus 1, Mickey, will you tell us what do you think we should do next?
You factor it.
Excellent. Good. So how do we do that?
This could be x plus 2, x minus 2.
You mean x minus 1.
Or x minus 1.
Excellent. So now here's the next step. We have to understand that x approaches 1 really means x minus 1 approaches
0.
Good. And I do have my little box. I do have the little box inside sine, and I also have the box in the denominator. So what I'm asking now is, since these are the same, the limit of sine x minus 1 over x minus 1 is
1.
good. So then, can anyone give us the limit? I'm dropping now the limit operator because I'm applying it. And what will be the final answer? Anyone?
3.
Say it again.
Is it 3?
What happened to the numerator?
Oh, 1 over 3, sorry.
1 over 3. That's it. Okay. At this point in time, I would like to talk about 2 situations. I don't want to wait till chapter 4. This particular item is in chapter 4. I don't want to wait. I never do. So this rule or theorem is called L'Hopital's rule. And this is applicable only when we determine a limit. Only for limits with 0 over 0 or infinity over infinity, indeterminate cases. So what I'm going to show now is specifically for limits. and only in these two situations. Okay. And I have to choose an example that will be a little bit easier than what we had here, because the next section, which is the chain rule, will be used in something like this. So I cannot give you that example. So I'm going to give you a different example. So here it is. Limit from sine x over 3x as x approaches 0. So like any limit, we have to see what case is this, what type of indeterminate case is it. So can anyone tell us if it's one of the L'Hopital's rule?
It's 0 over 0, so yes.
So the answer is yes. So I copy the limit as x approaches 0. And I am allowed just inside the limit. I don't want you to get confused. Only inside a limit, and only if it's 0 over 0 or infinity over infinity, I am allowed to differentiate each by itself. I'm not differentiating the function, because then I have to use the quotient rule. I am differentiating the top first. So differentiating the top gives us what? Gives us cosine x, very good. And now separately, only inside a limit, only when I apply L'Hopital's rule, and only in 0 over 0 or infinity over infinity, the derivative of the denominator is
3.
good. So now the final limit answer and the limit operator gets dropped is,
1 over 3.
that's it. Well done. Did I know this from the beginning? Yeah. Because I have the box, and I know that this will approach how much?
1.
1.
So then the limit must be?
Third.
1 over 3.
That's it. Any questions?
So is this mostly useful when dealing with problems that have the trig identities in them?
Nope, any problem.
Any problem?
Any problem. So let me give another example. Limit as x approaches 1 from x squared minus 1 over x squared minus 2x plus 1. Okay. What type of limit is it? Or what type of indeterminate case? Or what is the first step?
Plug in.
Good. So what do I get?
0 on the top.
0 on the denominator.
Good. So then
Yeah.
it means that I can apply L'Hopital's rule. What is the derivative of the top? This is, we never ever do this otherwise, but it's inside a limit and it's 0 over 0. The derivative of the top is?
2x.
Good.
2x.
The derivative of the denominator is?
2x minus 2.
Please plug it in again. So the top is 2. Unfortunately, the denominator is 0. At this point, I need to look at the limit as x approaches 2 from the left of 2x over 2x minus 2, and the limit as x approaches 2 from the right of 2x over 2x minus 2. So the numerator goes to, in both cases, is going to be a positive number. The denominator goes to 0 for sure. But 2 from the left, what is the sign? 2 from the left, meaning x is 1.9. So 2 times 1.9 minus 2, what type of answer would that be? Oh, I'm sorry. So one from the left, sorry, one from the left, which is 0.9. One from the left with 0.9.
Negative.
Very good, thank you. And the other one with 1.1 will be positive. Therefore, I have to come back. Only now I can conclude that that is DNE. If it were a DNE, I would have, and if it were 0 over 0 again, I would have had to apply L'Hopital's rule again, as many times as I encounter 0 over 0 or infinity over infinity. Do we need more examples or can we move on?
So eventually it'll actually get to something.
Sometimes, not always.
Yeah.
Yep. Not always.
How many layers deep do you know to take it?
As long as you still have 0 over 0 or infinity over infinity. You can apply it as many times as you have 0 over 0 or infinity over infinity. Of course, you're not going to apply it if you get 2 over 0. You can't. Of course, you're not going to apply it if the answer is 3. You're done, right? But as long as you have 0 over 0 or infinity over infinity, you will apply L'Hopital's rule as many times as you need. Okay, finally 3.4.